Once a year, in the freezing extremes of China, an army of workers builds a megacity out of nothing but solid ice. But how exactly do they do it? The answer is a massive logistical operation where 10,000 people construct a colossal metropolis larger than Vatican City in just 30 days. To pull this off, they must harvest thousands of tons of ice from a frozen river a full year in advance, forcing it to survive the summer heat without melting. This mega project costs over $500 million, only to stand for 60 days before completely melting away. Let's dive in and see how this engineering marvel is built from the ground up. Building the biggest ice park in the world is a race against time that starts long before the first visitor arrives. Because construction begins in November, weeks before the river freezes deep enough, the team harvests ice in January and stores it for 10 months. This ensures the foundation of the park is ready the moment the water freezes again. Motorized circular saws carve miles of parallel tracks, cutting deep to create a massive uniform matrix. Once the saws establish the grid, raw human force takes over. Teams use heavy steel bars to snap the ice along the saw lines. This simultaneous hit ensures the ice snaps in a clean, straight line. It's a process of timing where one wrong move could shatter the block. An army of 10,000 workers needs to harvest 7 million cubic feet of ice in just 3 weeks. That's the equivalent of filling 80 Olympic-sized swimming pools with solid frozen bricks. A project of this magnitude requires unique natural conditions. As the sub-zero air freezes the surface of the Songhua River, the water below continues to move in a slow, steady current. This constant flow acts like a natural filter, flushing out air bubbles, minerals, and impurities as the ice forms. The result is a material that is 99% pure water, exceptionally strong, crystal clear, and perfect for building structures that will rise 14 stories into the air. But in this extreme temperature, the water is always trying to refreeze. This is a constant race. If a block stops moving for even a few minutes, it can flash freeze back into the river and shut down the entire production line. Each block can weigh up to 1,000 pounds. To move these heavy pieces across the river, they cut narrow channels into the water, turning it into a fluid conveyor belt. Because ice is naturally buoyant, workers can glide these half-ton weights toward the shore with a simple push. At the end of the channel, mechanical ramps pull the ice onto solid ground. These extraction tracks use rotating chains with steel hooks to catch the floating ice blocks from below, ensuring they stay locked in place as they leave the river. As one crew breaks the ice, another guides it to shore, keeping a non-stop flow of blocks to meet the 15-day deadline. When the ice is out of the water, the mission shifts into a massive transport operation. Forklifts and transport trucks work together directly on the ice to load and move the harvest. This massive assembly line stays on the river because it is the only flat, wide-open workspace large enough to handle the traffic. The trucks head to a storage yard on the edge of the park grounds. This site is located just a few hundred yards from the riverbank. This year, the convoy will make over 1,500 individual trips to move the necessary inventory, covering more than 4,500 miles. That's like going from New York to Los Angeles and back. At the yard, excavators stack the blocks into ice mountains. One pile contains about 20,000 blocks, weighing over 9,000 tons. These blocks have to survive nearly a year in storage before they are finally used to build the city. To keep them from shrinking or melting away, the team relies on a physics principle called the cold sink effect. Cold air is heavier than warm air, so it naturally settles at the bottom and stays trapped between the blocks. The center of the pile is so frigid that it forms its own internal refrigeration system, remaining well below freezing even in summer. But keeping the foundation cold is just as important as keeping it dry. The soil here is layered with gravel to allow for drainage and prevent the bath effect. If even a small amount of water pools at the bottom, it would trap heat and melt the foundation of the stack. The yard also runs 24 hours a day. It is a harsh environment, where crews often face 40-mile-per-hour winds blowing off the open river. Once a mountain is complete, workers wrap it to ensure it doesn't melt. First, they lay down straw mats. Think of each straw strand as a tiny hollow thermos. It traps air, which is a terrible conductor of heat. These millions of air pockets act like a wall that stalls the summer warmth. This is the same principle that explains why a thick wool sweater keeps you warm in winter. On top of the straw, the team adds another layer of protection: plaques of white foam and giant white tarpaulins. Like a white t-shirt on a hot day, these surfaces act as a massive mirror, bouncing solar radiation back into the atmosphere before it can ever reach the ice. This setup is so effective that the ice loses less than 10% of its mass over the entire year. The ice mountains are now entering a long period of hibernation. 10 months have passed since the harvest. It is now November, and the ground has frozen solid once again. The team is now on a strict schedule. They have 30 days to build a city that covers over 250 acres. That's roughly the extension of 190 football fields and more than twice the size of the Vatican City. It is a massive undertaking that requires every minute to be used wisely. Because the central tower will reach over 108 feet high, it cannot rely on ice alone. To handle the immense weight and height, engineers must first construct a massive metal skeleton. This steel frame acts like a spine, providing the structural integrity needed to support millions of pounds of ice. Without this internal reinforcement, the tower would be at risk of shifting with the wind or collapsing under its own gravity. Most people think of steel as indestructible, but at minus 20 degrees Fahrenheit, regular metal undergoes a dangerous change. It loses its ability to bend and becomes as fragile as a pane of glass. If engineers used standard construction steel, the entire tower could fail. To prevent this, the team relies on a specialized low-temperature steel designed to stay strong when temperatures drop far below freezing. This metal is made with a unique recipe that includes extra minerals like nickel or manganese. These elements prevent the metal's atoms from locking into a rigid pattern when the temperature drops. As a result, the steel remains tough and slightly ductile, meaning it can deform without breaking. Welding this metal is also a high-stakes task. A torch is thousands of degrees, but the air is well below zero. This extreme temperature jump would cause regular steel to crack instantly. This special alloy is designed to handle that heat shock, ensuring every joint remains solid. The steel frame is hollow, leaving a path for the miles of electrical wiring that will make the tower light up. The crew only has a few days to get this frame upright. They assemble large sections on the ground first and then lift them into place carefully. If the base is off by even an inch, the top of the monument could lean dangerously. While the tower rises, excavators on the other side of the park shape a huge hill made of dirt. This acts as the base for the Grand Slide, the park's most popular ride. The goal is to create 2 long, winding paths for people to descend on sleds. But before any ice is laid down, workers set up the essential infrastructure on the hillside. When the sun goes down, workers go up in metal baskets to check the highest joints. Bright orange sparks shower from a distance while they weld the steel together in the dark. The electrical network is the absolute foundation for the entire city. It consists of over 93 miles of cabling, enough to stretch from the bottom of the Grand Canyon to the rim and back nearly 10 times. The primary risk here is thermal moisture. Even in a deep freeze, thousands of internal LEDs generate enough heat to melt the ice. If this moisture seeps into a connection, it triggers an arc flash, a violent electrical explosion that could black out the entire park. To prevent this, every joint is triple sealed in waterproof housing, ensuring the city stays powered through the winter. At sunset, the metal frame is finished. The team is ready to bring in the first heavy blocks of ice to cover the steel. After more than 10 months in the dark, it is time to see how well the ice has survived the summer. At the storage yard, workers begin the task of pulling back the heavy covers from the massive mounds. Removing these layers is a race against time and temperature. If the insulation is taken off too quickly, the sudden exposure to the air can cause the blocks to develop surface cracks. Direct sunlight is also a constant threat. Even in the cold air, exposure can begin to dull the crystal-clear surface of the ice. Over the year, moisture and cold have welded the straw and the foam together. Workers must shave away this fused layer to get the ice clean. Underneath, the blocks are often stuck together after months of sitting under their own weight. These irregular blocks won't go to waste. They'll be used for the internal structures of the larger buildings, while the more uniform and visually refined blocks will be reserved for the exterior. The yard is now a busy loading zone. Operators use heavy machinery to lift the blocks onto a fleet of waiting trucks. News crews and onlookers gather to watch the mobilization, as these reserves allow the team to start building weeks before the river is ready for a new harvest. Small utility trucks carry several blocks at a time, and excavators are used to lift them directly from the giant piles into the truck beds. This high-speed handoff is where simple mistakes happen. Upon arrival, workers sort the blocks by quality. But as the work progresses, the weather begins to turn. When gusts reach dangerous speeds, the risk of a block falling or a worker being injured is too high to ignore. The engines are turned off, and the crews stop all vertical construction. As wind halts the tower cranes, site managers redirect the workforce. Labor shifts to the super slides. This 1,600-foot track spans the length of 5 football fields and requires a massive ground-level mobilization. Even in these harsh conditions, work continues, ensuring that every hour of the deep freeze is used to move the project toward completion. Ground crews also assemble the Ice Tulu. This circular building is a tribute to Chinese architecture, where the curved shape allows each block to support its neighbor. If one piece is out of place, the circle loses its strength, and the whole structure can cave in. Next day, the high winds finally break, allowing construction to resume at full capacity. But the previous delays have consumed valuable time. To protect the schedule, site managers push the entire operation into overdrive. The site absorbs a synchronized workforce of 10,000 people, functioning like a highly industrialized city. Electrical teams race against the temperature, untangling miles of high-voltage cable. These heavy-duty lines must be precisely routed before the surrounding ice completely locks them out. Workers lay the first ice blocks for the central tower. This bottom layer must be flawless. A single hidden crack could shatter the base and bring down the whole structure. Once secured in place, workers carve them into shape. Meanwhile, snow cannons produce a massive volume of artificial snow. Loaders and dump trucks move the material to be carved into detailed landmarks. This snow also forms the park's ground, creating a walking surface that fits the rest of the frozen landscape. The snowflake and star patterns on the ground are more than just design. This geometry acts as a structural raft, spreading the tower's weight across a wider area. This prevents the 108-foot monument from sinking or leaning if the ground temperature shifts a few degrees. Crews get one shot at the lighting. Once the next layer is stacked, the LEDs are locked in a frozen vault. If they fail, they won't be able to repair it. Since the ice is 99% pure, the colors stay sharp and vibrant, even through feet of solid ice. Suddenly, the project faces a rare and unpredictable enemy, a winter thaw. When warm air spikes temperatures up to 39 degrees, the ice begins to soften, making it too weak to support the weight of the massive towers. To prevent a collapse, site managers immediately halt all high-level construction. Work on the main tower and the grand slide is suspended, and the massive cranes are powered down. Simultaneously, the snow cannons are shut down to prevent slush from forming on the foundations, and the transport of ice blocks slows to a crawl. While the landmarks are in a holding pattern, the workforce pivots to ground-level tasks that don't rely on the sub-zero cold to stay secure. This shift allows the team to finalize the warm castle. These massive, white-domed pavilions provide 54,000 square feet of heated space, offering visitors a vital refuge to rest and eat once the park opens. A standout piece this year is the Pony Family, a monumental snow relief designed to frame the park's south gate. This sculpture is a tribute to the upcoming Year of the Horse, the zodiac animal that will take over when the Lunar New Year arrives in February. It is a central cultural landmark, representing vitality and strength. Halfway through construction, And once the Songhua River reaches 12 inches in depth, the team pivots from their finite reserve to an inexhaustible supply of fresh ice. The cost of maintaining the ice for a full year is high, so harvesting new blocks once the river allows, it makes the project cheaper and faster. While the year-old blocks have slightly rounded edges from summer storage, these new bricks are perfectly sharp and untouched by heat. They are also significantly thinner, about 1/3 the thickness of the stored reserves, making them easier to handle and faster to lay. The harvest itself has evolved. Where teams once used ropes and body weight to pull slabs, motorized saws and winches now do the work of hundreds. This shift from manual labor to industrial machinery is the only way the crew can process enough volume to meet the 1-month deadline. A block pulled at noon is often part of a wall by sunset. This speed is what allows the crew to finish the massive park on time. As the seasons shift, the most popular feature of the park begins to rise: the Grand Slide. The run begins with a steep incline, leading into a midsection with a giant turn. From there, the track flattens into a long deceleration zone, ending at a solid ice wall that brings the sled to a complete stop. Stretching over 1,700 feet and designed with a Great Wall theme, it is the fastest progressing project on the grounds. In just 16 days, crews complete 24 parallel tracks. Specialized blades carve square-shaped channels that lock the sleds onto a fixed path. Visitors endure up to 7 hours in line for a descent that lasts just 40 seconds. The slide operates at a relentless pace, launching its final rider at exactly 1 minute before midnight. The scaffolding provides the platforms and walkways needed to carry tools and carefully place heavy ice blocks as the towers grow taller. In normal construction, you would bolt this metal frame directly into the walls. But ice is brittle. If you try to drill a hole into it, the pressure might shatter the block. To keep the building safe, the scaffolding surrounds the tower without touching it. Another reason the metal must stay away from the ice is heat. Even in these conditions, metal absorbs energy from the sun. If the scaffolding touched the ice, it could melt it and drill into the building. To prevent the metal from sinking into the ice below, the crew places wooden plates under every metal pole. This ensures the scaffolding stays stable while the workers climb to the very top. Since it first opened, the park has expanded dramatically. In 2001, it covered about 4.3 million square feet and featured around 20 main ice structures. By 2026, it has grown to a record 13 million square feet with more than 100 buildings, including palaces, bridges, and towers. The park is rebuilt from scratch each winter, with new themes, layouts, and architectural styles every year. This edition highlights designs inspired by guest regions such as Belgium and China's Shandong and Fujian provinces, turning the park into a global gallery of cultural landmarks. Construction has also become much faster. What once took a small team nearly 6 weeks to hand-carve is now completed using cranes and power saws in under 3 weeks. This efficiency will allow the park to open on December 18th, the earliest in its history. Attendance has grown just as quickly, from about 500,000 visitors in its first year to an expected 3 million this season. While the city rises on land, a separate engineering challenge takes place on the Songhua River, a 1:6 scale replica of the Liaoning aircraft carrier. Unlike other structures, this monument is built on an industrial barge floating in the water. Building on a boat creates a stability risk. If weight shifts to one side, the barge tilts, potentially dumping the ice into the river. To prevent this, Every block must be balanced. When a team places ice on the left side, another team must place a matching block on the right. This keeps the weight centered and the barge level. The replica is 230 feet long and needs 353,000 cubic feet of ice. Workers use scrapers and hand saws to carve the hull, shaping the ice to mimic steel plates. Because it sits on the damp river, blocks fuse together faster than those in the main park. At night, high-power internal LEDs illuminate the carrier. This blue glow creates a sharp silhouette against the dark, open river, visible for miles. But long before the 14-story towers, Harbin's frozen skyline began with a single candle. During the Qing dynasty, dating from the 17th to the 20th century, local fishermen on the Songhua River faced a problem. The Siberian wind would instantly blow out their lanterns. To fix this, they filled a bucket with river water and let it freeze just enough to form a shell. Like this, they could put the candle inside, where it was protected from the winds and stayed lit for hours. In 1963, the city turned this folk craft into the first formal ice lantern show. Using only hand saws and picks, artists carved river ice blocks into animals, flowers, and miniature buildings. Then, they carved holes into the ice and placed light bulbs inside to make them glow. In 2001, the Ice Lantern Show was merged with the Heilongjiang International Ski Festival and got its new name, Harbin International Ice and Snow Sculpture Festival. As the ice towers reach their final height, work shifts to the massive snow structures. These are built last because snow erodes quicker than ice. If artists carved the details too early, the wind and sun would blur them before opening day. The process starts by creating a monolith. Workers build massive wooden frames, blowing in artificial snow and compacting it in layers. This pressure bonds the snow crystals into a solid block with the density of limestone. To transform this building-sized cube, artists work from the top down. As they carve, the waste snow falls to the ground. By finishing the peak first, they ensure the debris doesn't bury or damage the finished details below. Every year, the centerpiece is the Great Snow Buddha, a 100-foot-tall spiritual anchor representing blessing and peace. A team of 30 artists works in unison to maintain perfect proportions. For rough shaping, crews use chainsaws and shovels to remove bulk material. They must work with absolute precision. Unlike ice, snow cannot be welded back together once removed. As features emerge, the tools become smaller. At sunset, the Buddha will be bathed in pure white floodlights. This highlights the shadows and depth of the carving, giving the snow the appearance of polished marble. The city's crowning achievement is the main tower, Harbin's tallest and most complex structure. Extreme cold and rising wind speeds turn the placement of the final tiers into a high-stakes race for masons and crane operators. The tower's strength comes from its hybrid design. As temperatures drop, the ice contracts and grips the internal metal skeleton. This thermal bond fuses the materials into a single, rigid unit, providing the monument's ultimate structural integrity. This allows the 141-foot spire to withstand 40-mile-per-hour gusts of wind. Once the last block is secured and the scaffolding is removed, The 14-story monument stands as the glowing anchor of the 13 million square foot park. Even in the extreme cold, the sun is a constant challenge. Its rays can slightly melt the surface of the ice, causing small cracks or making the clear blocks look cloudy and pitted. To keep the structures looking perfect, workers use a simple but effective tool: slush. By mixing crushed ice with a small amount of water, they create a thick frozen paste that acts like ice mortar. They apply this mixture to any gaps or sun-damaged spots. Because the air is so cold, the slush freezes almost instantly, welding the damage shut and restoring the building's structural integrity. This daily patchwork ensures that the ice structures stay strong and the intricate carvings remain sharp for the entire 2-month season. "10,000 workers, 14 million cubic feet of ice and snow. Every pillar, arch, and spire you see was pulled directly from the Songhua River and carved in temperatures that can reach -20 degrees Fahrenheit. This is the most concentrated engineering effort on the planet. From the 141-foot-tall main tower to the 98-foot-high Great Buddha, this city is a structural miracle, a hybrid of steel and ice that defies gravity through the sheer power of the cold. After 22 days of non-stop mechanical chaos, the machines have finally gone silent. Before the gates open to the millions, the city stands in a moment of perfect frozen stillness. It is a temporary metropolis, engineered to exist for only 60 days. It is built using ice harvested from the city's river, destined to shine brilliantly before the spring sun melts it back into the water it came from. The 26th Harbin Ice and Snow World is ready to open its doors. Even after the construction is finished, the park requires constant care to keep it safe for the millions of visitors. Every morning, before the gates open to the public, a fleet of specialized vehicles takes over the plazas. These are snow groomers. Throughout the day, thousands of footsteps pack the snow into a slick, hazardous crust. To fix this, the groomers traverse every corner of the park, breaking up and leveling the surface. The gates finally open, and the silence is replaced by the energy of millions. The Harbin Ice and Snow World isn't just a gallery of monuments. It is an interactive metropolis that operates from 10 a.m. to midnight daily. During its short 2-month season, which typically runs until late February, the park welcomes an average of 30,000 to 50,000 visitors every day, totaling a record 3.56 million people by the time spring arrives. The park thrives on a mix of high-speed thrills and cultural spectacle. Tourists plummet down the 1,709-foot Grand Slide, while hot air balloons provide a panoramic view of the skyline. The Ice and Snow Grand Stage hosts a variety of concerts, shows, and performances, while the Dream Grand Stage, inspired by the Yangmingtan Bridge, serves as the park's artistic centerpiece. The park also hosts international ice sculpture competitions, where artists from around the world carve intricate masterpieces live. For 60 days, this city of ice stands as the brightest metropolis on Earth. But its beauty is temporary. When the spring sun arrives, the lights fade and the structures are dismantled, returning 14 million cubic feet of water back to the Songhua River. Every pillar, palace, and spire will vanish, leaving no trace of the engineering marvel that once stood here. The city dissolves back into the water, surrendering to the seasons. But, as the gates close, the cycle is already in motion. Deep in the storage yards, the first blocks of next year's city are entering hibernation. They wait for the deep freeze to return, so this metropolis of ice can take shape once again.